Welcome. So what I'd like to do is show you how to graph a line, or write an equation of a line that's going to be perpendicular to our equation y equals 4x plus 2/3. That's going to go through the point 8, 5. Now remember, when we're talking about perpendicular lines, there's a couple things that we know about perpendicular lines. One, they intersect at a 90-degree angle, and also their slopes are what we call opposite reciprocals. So automatically looking at this equation in slope-intercept form, one thing that I can determine is that my slope is going to be m equals a negative 1/4, as that is the opposite sign of my slope, and it's also the reciprocal. Now the next thing I know is I have a point, which is 8, 5. Now the point, remember, we can label that as x1 and y1, right? Because that represents a point that's on our line, and that on our new equation has to go through that point. So by using our point slope form, which is y minus y1 equals m times x minus x1, we can plug in this point in for x1 and y1 because we want to leave the y and the x so that we can represent all of the points. Because this equation, what this does is this equation represents all of the points for all x and all y coordinates that lie on the line. Well, we're given one example, so we're going to plug that point in to make sure we find the exact values, which we already know our slope is going to be a negative 1/4. So let's go and plug it in. So I have y minus y1, which is 5, equals our slope, negative 1/4, times x minus 8. All right? Therefore, I can't simplify the left side, but the right side, I can apply distributive property. So I have y minus 5 equals a negative 1/4 x plus 2. Now, I just need to solve for y, so I add 5 to both sides. Therefore, I get y equals a negative 1/4 x plus 7. And therefore, that is my new equation that is going to be perpendicular to this line, but also goes through the point 8, 5. Thanks.